Okay, if there's time, there may not be, but let's go ahead and circle back and do a quick video on example 2, this word problem. We have a specific type of stew, and that's arbitrary. This is a cooling problem, though I'm really curious about that now. When you take it off the stove, the temperature is 212 degrees Fahrenheit. The room temperature is 70 degrees Fahrenheit. And the cooling rate is this factor here, some percentage it looks like. How long will it take to cool the stew to a serving temperature of 100 degrees Fahrenheit? Okay, so in the text, I didn't really appreciate this. They kind of, sometimes in our book, they like bury formulas or important information in graphics. So here's Newton's law of cooling. So this is the formula we're going to use. We have to kind of know what these things mean. So T stands for temperature. So this T sub naught is the starting temperature. Okay, so naught means at the beginning. So that's going to be our 212. Start means at time 0, right? So that little 0 means right at the very beginning. So the starting temperature is 212. And then our serving temperature, that's our resulting temperature, is 100. So when is it going to equal 100? So that's like our resulting. And then R is the room temperature. So T sub R is our room temperature. So that will be 70 for both of those places. So that's the temperature of the room. The small r is the same thing it meant in our all of our interest formulas. It's some sort of rate. So it is the negative is already there, so that means it's cooling off. So we're going to put this r value there. So let's go ahead and write this out. So my ending temperature is 100. When is it going to equal 100? It starts at 212 minus 70. So that's my start minus the room temperature times the natural base E to the negative 0.046 T plus 70. Okay. So when everything's filled in, I see that I only have one variable, and it's asking how long will it take to cool. So I know my answer is supposed to be some sort of time, and lowercase t typically means time. So I think we're in good shape. We only have one variable to solve for. So I'm going to start peeling off layers, starting on the outside and working my way in to get t by itself. So the first thing I'll do is I'll subtract 70 from each side. So that gives me this. And then this is also just a constant. I can subtract 212 and 70. So that will be 142. And then e to the negative 0.046 t. So I'm already in a lot better shape. I do have this kind of this constant here, 142. So I don't have my exponent by itself. So I'm going to go ahead and divide by 142 to get rid of that. And I wonder if I need, I think I can get away with a decimal approximation here. This will be, let's use at least 3 decimals though. This is going to be approximately 0.211 equals e to the negative 0.046 t. And so now I have one of the types of problems I've seen a lot of today. I have a single logarithm, or sorry, a single exponent equal to something. So I'm going to rearrange this and put it in logarithm form. So I'm going to start with my base e and use that as the base of my logarithm. So that, let's go ahead and move this over here. So I'm going to take the natural log, that's the log base e of 0.211. That's going to be my argument. And that equals my power, negative 0.046 t. So now I've all I have to do at this point, so I rearranged the form, wrote it in logarithm form. All I have to do now is divide by this coefficient to get t by itself. So when I divide both sides by 0.046, 0.046. I'm going to put this in my calculator. It's going to be the natural log. Let's clear that out. The natural log of 0.211, close parentheses, and so that's a value, and then I will divide that by negative 0.046. And the answer is 33.82. So there's a critical piece of information here. I assume time is in minutes, seconds, hours. Those don't make sense. It's not given to me in the formula. I'm sure it's somewhere in the book, but I'm going to go with minutes. Maybe I'll check my answers and see if that's right. It turns out it's pretty darn close. Yeah, it's actually, the book got 33.8 and they are calling it minutes. So yeah, not bad.